Now that we can actually get into low voltage, how do we start off? Well, the first machine you're going to want to make is a basic steam turbine. What this does is it turns the steam that you've made into energy. Then, what we're going to need is tin cable. At least that would be my recommendation. So let's have a look at the tin cable and talk about it. The max voltage is 32, in brackets LV. The max amperage of a tin cable is 1. And the loss per meter per amperage is 1 EU volt. And that means that basically over each block, it's going to lose 1 volt. So if you've got 32 volts going through, we've got 32, 31, 30, 29, 28, 27, 26, 25, 24, 23, etc., etc. There is some loss over distances with these cables. Now, when we look at the cables, what you'll see is that the tin cable has a max voltage of 32 and a max amperage of 1. A 2 times tin cable made with 2 times tin wire, which is literally as shown, actually has an amperage of 2, but the max voltage is still 32. So the amperage is how many amps or packets, I guess you could say. Yeah, let's say packets of voltage. If I have one steam turbine running here, then we have 1 amperage. If I was to add another one on, and then I added, on my cable, obviously these aren't connected, but let's say they were connected, so sort of go like this, for example, then the amperage would be 2. So you could basically see it as how many packets are being sent over the system. Voltage is the one that I would pay much more attention to. If we tried putting in a much higher voltage than 32 into these low voltage machines, they would explode and the wires would burn up. So 32 voltage is low voltage. Like you can see here, LUV is 32768 voltage with a max amperage of 4 on those cables. Silver cable is high voltage at 512, etc., etc., and it's 128 at medium voltage. So we are working with low voltage at 32 voltage. And that is obviously what our basic steam turbine will be making. If you want to turn it off, you could just click this power button in here. And now that we have our rubber, of course, we can also make a rubber soft mallet. Clicking this on the machine will also turn it on and off and will change basically the state of the machine. If there's any issues, it'll be shown up here. You can see it says insufficient output, so it has nowhere to output the energy it's making. And you can see the voltage here and how much energy capacity it can actually store and how many buckets it can store. This little button here shows you basically the input and output. On this one, it's pretty simple. The red bit is where you output the energy, and you can input the steam from anywhere else. So we can now upgrade our basic machines, or at least get some new ones. So we have the basic LAF, for example, or LAF, I think it's pronounced. And what we could do in here is we can make things much more efficiently, like our rods. For example, ingots we can turn into 2 rods. But that's only 1 ingot into 2 rods, whereas making a rod normally would be 2 ingots into 2 rods, which I've just realized isn't actually any more efficient. On some of these recipes, it really, really is. Like, for example, on a bronze ingot into 2 rods, you could see the duration, how much total EU, which is electronic units or electricity units, it uses, and the actual usage, it's going to use 16 EU per tick, and you can obviously see it's low voltage. Then we have the basic bender. This basically bends things, and what you'll see in here, specifically on here we're looking at medium voltage, but it does apply for anything we're using, is that if I were to turn 2 HSLA steel plates, which we obviously can't make yet, into a double HSLA steel plate, it needs the plates, but also a programmed circuit with a configuration of 2. Can you see on green it says 2? LV, if we want to make cobalt ingots into cobalt plates, we need a configuration of 1. So when I go into the machine, you can see there's a circuit setting. I click on it, and I can press 1, and that will change the circuit configuration to 1. It'll say that you need to put a circuit in, but you actually don't need to input a circuit. You can just click these to set it to whatever number you want. I would personally recommend that you make not 32 of them, but as you need each number repeatedly, just make another one for it so that you can automate making big batches of items rather than having to do it, keep changing the number and doing it manually. Early game, of course, you may only be able to afford to make 1 or 2 of them and may have to keep changing this as you need different recipes. We have the wire mill, which will help you make wires much more easily. This is where you put your ingots into, nickel wire or tin wire, etc., etc. And you can make all sorts of wires in here with different configurations. We have the basic extractor, which is, of course, an upgrade from your steam extractor. And this does the exact same thing, but remember, when it says here ultra low voltage, well, now you might be actually able to do things that need low voltage instead. There's a fluid solidifier, which solidifies fluids using molds that you've already got and we've spoken about. And then lastly, I want to show you is the energy converter. You may already be making energy from different mods, and you can make this LV energy converter. So you can see here, you could put in any side here energy from another mod, and it will output it at low voltage out of this red socket here for you. Get your soft mallet and right-click it, and now you'll see it will say converting electronic units. So it'll actually put 32 low voltage EU in and will output 128 forge energy. Right click it again and it will change to forge energy in and electronic units out at low voltage. So if you have another mod making power, you can pipe it into this green slots and then just output your low voltage here for your machines. And obviously what I'm going to be doing is hooking these up to my steam, and it's wire cutters that you use to connect them for the actual cables here. So I'm just going to, connect up these machines, and you can see the EU is piling into the machine and powering it so that we can use them for, whatever we may need. If we want to get on to medium voltage, we are going to need a good, and this is basically our goal here, a good electronic circuit. So many of the things I'm about to be showing you are going to be to make this good electronic circuit. I'm going to show you the machines, etc. you'll be needing along the way, and of course it's all chaptered below. So diodes we're going to need, which is going to be made in an assembler as shown. We're going to need phenolic printed circuit boards, which need pretty much just phenolic circuit boards, again made in an assembler using glue and things like that. And we're going to need some basic electronic ones as well, 3 of them just to make one good one, steel plates, etc., etc. So let's see what we need to do in low voltage. To actually make all of these machines, one thing we are going to need is wrought iron in the low voltage era. Wrought iron is a bit of an annoying one in the fact that when we look at a wrought iron ingot, you'll notice 9 nuggies equal 1 ingot, as you'd expect. You can also use a low voltage or steam compressor to turn 9 nuggets into an ingot. The nuggets, however, are simply made by smelting up iron nuggets into wrought iron nuggets. A very simple recipe, but often overlooked by many people when they're like, hey, how do I actually make this ingot? I can't find the recipe. Well, you have to smelt up iron nuggets and then turn it back into an ingot. The first item we're going to need, and the easiest for our good circuit boards, which allows us to go to medium voltage, is the phenolic printed circuit board. So the silver wire that you'll need for it at this point would be made in a wire mill. You configure your wire mill to 1, and then you have the silver ingot in here, and it makes 2 silver wire. Whereas at medium voltage, we can use something even simpler like an extruder. But in low voltage, we can only use the wire mill. Now, to make the phenolic circuit board itself, we need to use a new machine called an assembler, and we need to configure this to 1, put in wood pulp, and have glue coming in, and that will make them. So here is the setup before me. I have my power coming in from creative energy, but obviously you could use a basic steam turbine generator. I then have, because there's a few amps going in here, you can see here the amperage is 1.5 out of 2 amps. So you can see when you're looking at the cables how many amps are going through them so that you never end up burning your cables away. If you do use too many amps, the rubber on the cables will be burned away, but the machines will be okay. If you put too much voltage in, that is when the machines will explode. So I have a basic macerator here, and what I'm putting into here is oak logs. And I'm macerating in the basic macerator the oak logs into wood pulp. I'm then exporting them with a small tin item pipe into my basic assembler, and as you can see, the wood pulp is building up in here. So in order to export from the basic macerator, I'm going to go into it, go into this config one, click and drag around so I can see, and I can just double click on auto, which is auto export, on the side where my pipe is, and it will automatically export the pulp on that side into the assembler. Now, this should automatically go in, and as you can see, the wood pulp is all in here. Then we need to make the glue. So I have a basic centrifuge, and I'm putting in sticky resin from rubber trees, and this is getting the liquids come down here, but it's being piped out immediately, and you also get some raw rubber pulp as well, which you would have probably already known. And in the output here, what you actually need to do is make sure you click on the side you want, and then click on this button to make sure you're auto-outputting the liquid, because these ones down here do the items. This one here is the liquid output of the machine, and that can confuse some people. And then put it to a fluid pipe going into your assembler. There we have the bucket of glue, the wood pulp, and it's going to automatically start making them. If yours isn't working, but it's all in here, then the thing you've probably forgotten is that in the circuit settings down here, you must click 1, because that is what the recipe requires. So when you look at it in JEI, you can see here, it says 1 in programmed circuit. And that is how you make the Phenolic circuit boards. And then just put it with your silver wire, and you've made Phenolic printed circuit boards for your good circuits. That's the easy part of making the good ones to get into medium voltage. On our way to medium voltage, we're going to need oxygen. And this is my oxygen setup here. This is fully automated oxygen. You don't have to fully automate it, but I would. So what I'm doing here is I've got everything at low voltage, and I'm being naughty and just using creative energy underneath. If you want to do the same in a super flat and test things out, just place one down, click low voltage and set it to active, and put it next to machines. But obviously you could just pipe in your voltage from your likely going to be using steam turbine still. So what I've got is a basic rock crusher, water and lava on one side. Make sure that they don't get jammed on these machines, by the way. So the input and the output need to be on separate sides. That's what, and I have it on auto, so it automatically pulls out the machine. So in the rock crusher, I have cobblestone, and it'll just make more and more and more cobblestone, as shown. Then going into a basic forge hammer, the forge hammer will crush the cobblestone into gravel. Pull out of the forge hammer into another forge hammer, and the gravel will turn into sand. Pull out of the sand from the forge hammer into an electric furnace, and turn the sand into glass. Pull out the glass into a basic macerator, where it gets turned into glass dust. Pull out the glass dust from the macerator into a basic centrifuge, and it gets turned into silicon dioxide. Pull out the silicon dioxide from the basic centrifuge and into a basic electrolyzer, where you will get silicon dust and also oxygen gas. So just to recap here, you're basically going basic rock crusher with cobblestone, and then just piping every item in this processing line. So forge hammer, electric furnace, macerator, centrifuge, and then electrolyzer. And yes, the oxygen gas will go into fluid pipes in Gregtech. The purpose of this tutorial that I'm making it for is for diodes, so that we can get our good electronic circuits. The diodes are really going to be what is tricky to make here, and we're making gallium arsenide dust. And it's a long process. This in front of me here is the EBF, baby. It is the electronic blast furnace, an upgrade to your primitive piece of rubbish, the primitive brass furnace over here. So this one is electric. Now, the interesting thing about this multi-block is that we can actually make medium voltage recipes even in low voltage. I'll show you how. So at the back here, what we've actually got is some 4x tin cables hooked up to a creative energy block with an amperage of 4, or you could just put a few steam generators on here. So what I've put onto it is 2 LV energy hatches at 2 amperage and 2 amperage, And basically what these LV energy hatches do is, because it's 2 and 2, it means that we can actually do medium voltage, because it makes like 1 amp of MV. It sounds a bit confusing, but just trust me, that's what it does. So the interesting thing about the EBF is you can actually do different coils, and the coils are these cupronickel coil blocks here. So to make the cupronickel coil blocks, what you're going to be seeing is the assembler. An LV basic assembler is fine, and you need some bronze foil and some cupronickel wire. Cupronickel is made with obviously cupronickel ingots. This is a new ingot that you won't have yet. We can make it in the alloy smelter with nickel and copper. So here you go, nickel ingot, copper ingot makes cupronickel. And then what you'll also see in the assembler is that you need to pipe in liquid tin alloy. So liquid tin alloy you would make in the basic extractor. You can see here it does require LV, and we can use any sort of tin to get the liquid tin alloy, and we put it into an assembler with these items, and we get the cupronickel coil blocks. So it is empty on the inside, as you can see here. And as you can also see, I've put on all these different items. So what I've put on here is an input hatch. Now the hatch is for liquids. So when I right click on the input hatch, you can see it's oxygen. But what you'll notice is it says ultra low voltage, whereas the output bus is low voltage. So let's have a look in the JEI here. What you'll see is there's a ton of output hatches. The ultra-low voltage output hatch has a fluid capacity of 8 millibuckets, or 8,000, so 8 buckets, whereas the LV one can hold 16 buckets. MV is 32. So what you'll see is that the higher you go, the more buckets it can hold. But you can actually mix and match. So I'm using an ultra-low voltage input hatch, because that's all I need right now. And you'll see in the assembler, using some glue, glass, and an ultra-low voltage machine hull, and setting the program circuit to 1, we can make the ultra-low voltage one. But I'm actually using, for the items, so the input bus, and the interesting thing about the input bus is ultra-low voltage has an item slot of 1, whereas low voltage has an item slot of 4 and 9 and 16, etc., meaning you can put more and more items in here. So the ultra-low voltage input bus, we only need to put cobaltite in here. What we're actually trying to make at the moment is it's arsenic trioxide. I don't know if I actually told you that bit yet. But this is more of a tutorial on how to use the EBF at the moment. We don't need to know the why, we just need to know the what. Whereas I'm using an LV output bus, so the input bus I'm using ultra-low voltage, because the recipe I'm using only needs 1 input. Obviously there'd be no issue using a higher one, but I'm saying to save resources at early game, you can do this. The low voltage output bus, however, can output 4 at a time. So if you're using a recipe, let's say arsenic trioxide, and you go to the electric blast furnace, you can see here that I need to input oxygen gas and cobaltite, and it will output sulfur dioxide, cobalt oxide, and arsenic trioxide. And it does say MV, hence why I said you need 2 LV energy hatches. And the coils required are cupronickel, so it does tell you the coil you need in your EBF, because you can use, as you can see here, loads of different ones. So I do believe that what it means is you must use at least cupronickel, and anything that's like above that should be fine. But what I'm trying to get at is, see how it has here 2 item outputs. If you use an ultra-low voltage output bus, which obviously would only be able to output 1 item, this recipe would not work, and it would just sit idling. And you may be thinking, well, what's wrong with it? That's because it needs the LV output bus, because this recipe automatically outputs 2 items. So you need at least the 4 slots, because there's not a 2-slot one, it goes 1 slot or 4. You need this 4-slot one so it can output the 2 items. But for the input, we're only inputting 1 item, and therefore the recipe's fine. And you would also need an ultra-low voltage output hatch for the sulfur dioxide that you're going to be making. So we also have on here a muffler hatch. This is where you get any waste products, and in this recipe it's tiny piles of ashes. So you just need to come up here and make sure that you're emptying it. And then we also have a maintenance hatch, and it says here, click the slot with an empty hand when required tools are in the inventory to solve problems. And it will tell you what ones to do. later on in the game, you can insert tape here to prevent problems. But sometimes it may need maintenance, and you just sort of click it in here. If you have like the tool, let's say it's a wrench, for example, you just click it in here with your empty hand if you have the item in your inventory, but it should tell you which one you need. So just to clarify again, the electric blast furnace, we have the actual block itself, and then the rest of the items you're going to be using are heat-proof Invar machine casing. And to make your Invar, you're going to need nickel and wrought iron. And again, you can do this in all different ways. I would use the alloy smelter, wrought iron, and nickel. And at this point, you should be starting to get used to how to look through the different Gregtech machines to see how you want to make stuff. Because what you'll notice is there's often many different ways to make things in Gregtech, which can be quite overwhelming or confusing sometimes. But that's what you'll be using, heat-proof Invar machine casings, and then you're going to need 2 LV energy hatches, so which I've got here. 1 ultra-low voltage output hatch or higher, so you can use an LV one if you want. 1 ultra-low voltage input hatch. 1 ultra-low voltage input bus, which is for the items. So hatches are for liquids, buses are for items, and an LV output bus. And then it's all on the top is heat-proof Invar machine casing, a maintenance hatch, and a muffler hatch, obviously I'm using LV for that, and your copper nickel blocks on the outside. You'll know you've done it correctly, because when I put these last 2 items on, notice how these items are grey? Suddenly it's all gone the same colour, which is green, and I can look in here, and it'll show you that the heat capacity is 1800. So you might be saying, well, how do I heat it up? It will heat up automatically if you're powering it, and it shows you the current maximum tier of recipes that it can be run with the makeup of the machine that you've got. The reason it's sitting idling is because my sulfur dioxide is full. If I just replaced this, broke it and replaced it, you'll notice it's working because the copper nickel actually lights up and the muffler hatch is blasting out pollution there. And you'll notice that we're getting our cobalt oxide and arsenic trioxide in there. So if you're actually not sure, go onto your electric blast furnace, the item that you're going to interact with, and press U. And then at the top here, electric blast furnace. No, not sorry, multi-block info. This one tells you the recipes you can make. The multi-block info shows you how to make it. It's a bit confusing in my opinion, but it shows you all the items at the bottom here. I personally found it confusing. Where it says all, click that, and it will show you the lowest layer, and then up one, and then up one, and then the top layer, and then all of it. So you go layer by layer, but you can add, more input hatches and buses depending on what you need. And when it says P0, this is the tier of the EBF. So tier 1, tier 2, tier 3, and you start seeing this is going to be at tier 3. Well, it says copper nickel still, so this is a bit buggy, but I don't know what thingy this is. Oh yeah, there you go, trinium and blah, 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 blah. But you can go up through the tiers as well and see what you need, basically. And obviously we're starting on P0. And there you go. So that is actually how you use the electronic blast furnace. The first items you're going to want to make once you have an electronic blast furnace is going to be arsenic trioxide dust. So what we're really trying to make here are diodes, which are these items here, basic electronic component. And what we're going to use the diodes for is going to be good electronic circuits, which of course take us into medium voltage. That's the whole goal here. So diodes. This is going to get quite complex, but I'm hoping at this point you already are understanding how to use basic machines in Gregtech, like the electrolyzer and the centrifuge and the basic assembler and things like that. So here we go, a diode. What I'm going to do in this tutorial is I'm going to work it back and then I'm going to work it forward. So I'm going to work it back from the end to the start and then the start to the end. That may sound confusing, but I often find working back is easier, so hopefully we can cover all the bases here. So to make the diode, in your basic assembler, you need to put in a small pile of gallium arsenide dust and fine copper wire with liquid glass. So I would have at the end of your assembly line an assembler. Liquid glass comes from extracting glass in a basic extractor. Very, very simple there. So that's that bit ticked off. Fine copper wire. You're just using your wire cutters or a wire mill. with a copper ingot with the program circuit set to 3, fine copper wire. Pretty simple again. The bit that is difficult is the small pile of gallium arsenide dust. So how do we make gallium, or gallium arsenide? Well, we can use a packer, an LV packer, set to 2 with gallium arsenide, or you can just put some gallium arsenide dust in your crafting bench if you want to do it manually. Gallium arsenide dust is made in the mixer. So you want to make a basic mixer, and this just mixes ingredients that you shove into it with arsenic dust and gallium dust. So gallium actually originally comes from bauxite ore. So what you want to do, if you see bauxite ore, you can see here that when you furnace it, you get bauxite dust. So this looks like a really confusing flowchart. But when we go down one, we go, okay, so we're not going to just furnace it into dust. We're going to put it in a macerator. And that macerator gives us crushed bauxite ore. When you then put the crushed bauxite ore through a basic chemical bath, you can see here you get sodium persulfate, purified bauxite ore, and 70% chance for gallium dust. What I want to do in this Gregtech tutorial is a bit different to my usual tutorials where I show you everything manually. I really want to help you kind of learn it for yourself in Gregtech because it is so complex and in-depth. And if you take complete hand-holding, you're just not going to get there. So I want to explain the concepts a bit more, if that makes sense. Hopefully it's going to work for you guys. So I'm kind of more trying to explain the flow charts and how to interpret them because I can't show you every single, recipe. It's just going to get insane. So what you look at this flow chart is go, right, I want to make this gallium here, feed it back. How do I get it? So if I look at purified bauxite ore, you can see here in the basic chemical bath, the crushed bauxite ore with sodium persulfate gives you purified bauxite ore and gallium dust. Well, a 70% chance at it. So you need to then make sodium persulfate. So what I'm doing here is I'm going, okay, I want to get here. So let me just press R for recipe on purified bauxite. And then look how much simpler it looks when we look at it from this angle. And I go, okay, so I know how to make the crushed bauxite ore. That's simply in a macerator from the ore. But how do I make sodium persulfate? And then we go, click on that. Oh, okay, I'm electrolyzing sodium bisulfate dust. And then I go, how do I get that? Well, we need to go in a chemical reactor. And what we're going to put in is salt, which you can literally just mine up, salt ore. And we're also going to need liquid sulfuric acid. Is that right? No, sorry. Sulfuric acid from Gregtech. So to make your sulfuric acid, what we're going to need is sulfur trioxide and water. And this is in a chemical reactor. A chemical reactor is just where you, again, pipe stuff in and it does stuff. So it turns these liquids into this. So sulfur trioxide is made in another chemical reactor with sulfur dioxide. And sulfur dioxide is made with oxygen and sphalerite dust, which you can just mine up. You get that from your, it's from sphalerite. So to go back, mine up sphalerite and put your oxygen into the electric blast furnace, which is going to get you zincite dust and your sulfur dioxide. So that's step 1. So get your EBF, put in sphalerite and liquid oxygen, and that makes you sulfur dioxide. Then what I want you to do is take that sulfur dioxide with more oxygen and put it through a chemical reactor to get sulfur trioxide. Then take that sulfur trioxide with water in another chemical reactor and you get sulfuric acid. What we do with the sulfuric acid, I've forgotten. With your sulfuric acid, we need to use salt to make, so yes, salt and sulfuric acid programmed to 1 in another chemical reactor will make you sodium bisulfate dust. You will also get hydrochloric acid as a byproduct, which we don't care about right now. Then you simply get that sodium bisulfate and put it through an electrolyzer to get sodium persulfate. And then that's where we get back to this bit. So you've got your sodium persulfate, and then you get your basic chemical bath and wash it through with a 70% chance to get gallium dust. So you can see here, basic chemical bath, your crushed bauxite ore with the sodium persulfate makes you purified bauxite ore, but you have a 70% chance to get your gallium. But we must wash it in the chemical bath with the sodium persulfate. So really, with gallium, the hard bit is getting the sodium persulfate. But just rewind this part of the video if you're not sure. Then, to get your gallium arsenide dust, we simply mix the gallium dust with arsenic. And arsenic dust is actually quite easy to get. You basically put your cobaltite through an electrolyzer, and you'll get cobalt dust, arsenic dust, and sulfur dust. So it actually is a way of getting some sulfur and arsenic from your cobaltite. And to get cobaltite, well, that is in the EBF. And quite simply, all you're going to do is power it with 4 amps, so 2 LV energy hatches, and pump in oxygen gas. But that will also get you sulfur dioxide. That's another way of getting sulfur dioxide, which you can obviously turn into sulfur trioxide with oxygen in a chemical reactor. So there's different ways of getting things, as you can see. So that's the sulfur dioxide, the oxygen, and you just pump in cobaltite dust, which come from centrifuging an impure pile of cobaltite, which you can get from just crushing it. So a forge hammer to crush the cobaltite ore into impure, and then centrifuging it to get the cobaltite dust, which you just shove into the EBF here to get cobaltite dust. So it is quite a long process, because that's where you then get your arsenic trioxide through. So then again, when we look at the diode, you can see here, just as a reminder, we need liquid glass, very easy to get. Small pile of gallium arsenide and your fine copper wire. The small pile of gallium arsenide is made from just crafting, either in a packer or just in the crafting table. And the gallium arsenide is made in the mixer with your arsenic dust, which you centrifuge your gallium arsenide to get your arsenic and gallium dust, or electrolyze your cobaltite dust into your arsenic. Yes, because you need gallium and arsenic. And then you get gallium arsenide. So that, everybody, is how you make diodes in Gregtech. Hopefully that wasn't too complicated, and I explained it in a way that actually made sense. But the key here to learning Gregtech is it can be quite complex, but what I do is I just follow things back. I go, right, I need a diode. I'm going to work it back. How do I make liquid glass? Okay, I make it through the extractor, easy peasy. How do I make fine copper wire? Okay, I make it through the wire mill or XYZ. Okay, how to make small pile of gallium arsenide? Okay, I need to make it from this in this machine. Okay, so how do I make this? I go back one. I go, right, macerator. Well, I haven't got the ingots, so I can't use that. Part grinding. Well, I don't have any of these things, so I can't do that. The mixer. Ah, this looks like it. Arsenide and gallium. Okay, so this is clearly the step before that I need to look into. So I then go, well, how to make arsenic? And I go through them all again. And I go, right, okay, electrolyzer. Oh, cobaltite dust. Well, I know I can make that in the EBF. So actually, this is where I'm up to. I then press the backspace button and go, right, gallium dust. How do I get that? Electrolyzer, sphalerite. Oh, I know that I can mine that up. And actually, when you start doing it like that, you realize it's actually quite simple. You just need to do it in piece by piece, step by step. And there we go. You've now made diodes. Once you've made your diodes, we can make our good electronic circuits, which need some diodes, your phenolic printed circuit boards, and some basic electronic circuits which you would have made to get into LV, and some copper wire. And there you go. You have officially made it to medium voltage. There is also a circuit assembler. You'll notice this as you get through Gregtech, things kind of get easier but also more difficult. Like you can make this is LV, a basic circuit assembler where you just put in two of these, one of these, two of these, and some liquid tin, and it'll just make it for you. So you want to start automating more and more as you get higher up. I hope you did enjoy the video. Click that subscribe button if you did, and of course leave a thumbs up. If you're looking for other mod guides, I do a hell of a lot on this channel. My actual goal on this channel is to complete every major mod in the entirety of Minecraft for Forge, Fabric, etc. If you look at my channel, I have a tech mod shelf, a magic mod shelf, a utility and standalone mod shelf, so ones that aren't in playlists. I also have now mod pack guides as a shelf. So at the moment, I am live streaming through RLCraft, and you can get that, of course, on my lives. I live every Wednesday and Saturday, and you can always see when the next scheduled stream is. And I play through the mod pack, and then I will also do separate guides on that mod pack. So if you are looking for specific mod packs, or you just want to come along and ask me some questions or hang out, you can also do that there. Do also just use the search bar if you are looking for a specific mod. And if you'd like to play with me, the mod pack that I do live stream, I do from our Patreon server, which of course you can join down below, which would massively support the channel, but also gets you access to things like that.